pay me all the time. They get the privilege of being on the slide here. And we're actually hiring right now. So, what a coincidence! So, if you want to join a cool company who has it in its heart to sponsor meetups like this and get cool people like Axel Fontaine talking about cool technologies, then feel free to join us. Or contact me first, yes. However. So thank you very much, and please enjoy. I assume you will introduce yourself, Axel Fontaine, and box views, and what those small thingies can do for us, and how fast everything gets going.
It's not too loud for you guys because I'm reasonably loud when I speak. Everybody okay? I'm blinded anyway, so I can't really see. Alright, so as Christian said, thank you very, very much for taking the time to come out tonight. I don't know if some of you had a few drops of rain on the way out, or at least decided to give up maybe the football match to come here. So I hope we're going to make it interesting for you. We have about, I think, 50-55 minutes ahead of us, and about 100 slides and a bit of a demo. So it's going to be pretty intense, and hopefully there will be a few interesting ideas or a few interesting concepts for you, or maybe some approaches that you haven't seen before that could be interesting food for thought. So today we're going to talk about immutable infrastructure, which is a topic that I strongly believe is going to be defining the future of how we treat our servers and our systems. So let's dive in just a second. A few words about myself. So as Christian said, my name is Axel Fontaine. I'm originally from Brussels, but I've had the pleasure to be living here in Munich for the last 10 years. So it's always fun to be able to go to a meetup or to a talk where I can come by bicycle and not have to take a plane somewhere. So that's quite nice. These days, some of you may know me as well through my open source project Flyway. Who's heard of Flyway before? So about 3/4 of you. So for those who haven't, Flyway is a tool or a library that helps you reliably evolve a relational database schema across multiple instances of your databases over time. So this is really, I think, something where you should look at using a tool to solve the problem instead of doing it manually. Any tool you use there is better than no tool at all. I'm also the founder and CEO of a company based here in Munich called BoxFuse. We specialize in deployment of JVM and Node.js-based applications on AWS. A lot of what you're going to be seeing today are the principles and the lessons learned of our journey there, and so hopefully some of those will be useful to you as well. So I think we have quite a busy agenda for the next hour. So I would say if you have any questions, maybe hold on to them till the end. I think we'll have plenty of time after that. People that are in a hurry are then able to go home, and then also if we hang around for a while, and we have plenty of time to answer all of those at the end. So let's get started. And we're going to start with our big time travel machine, and we're going to travel back to the wild times of the 20th century. So pretty wild, because we had these guys running around, and this was how we used to play music, and that was how we used to rewind it. So it was pretty exciting indeed, and we had this guy. And this guy loved it when a plan came together. So when his plan was to get a server, this is how he would do it. He would get on the phone, the old style with a call, then he would call his good friend Michael, and he would say, "Hey Michael, I would like to get a server," and Mike says, "Well, sure, no problem." And a few weeks later, he would receive a pizza box in the mail, which would then be screwed in the rack and connect the network to power, and then what? Still doesn't work. So he gets back on the phone and calls a young criminal from the western coast of the United States, that delivers him some criminal software which then gets installed and updated and enough we go. So for the longest time, this was actually the flow that we had to go through. And if you look there, we actually have three major components. First of all, we have the data center, then we have our server hardware, we have the software, and all that together is our classic on-prem storage. So you need to really master all these three things. And that's actually quite a challenge, or more than we would like to believe. If you look at what's involved here, it starts from rather mundane things like having to deal with having reliable power and backup generators in place, and having reliable networking and cooling and the proper airflow and flooring built, and things like physical security of the building must be taken care of, or even things like having enough physical space, because it's not enough to have space for your current infrastructure. If 2 years down the line you want to upgrade your storage, you can't just disconnect the old one, wheel it out, and then wheel the new one in and reconnect it. No, you need some time and some space to be able to have both at the same time and transition cleanly. So all these problems there are really quite mundane, and once you've solved all, then only do we get to the whole relationship with Michael, where we have to deal with making sure we plan our capacity ahead of time and deal with the finances so that we can then get all those sorted before we finally get on to the software side of things, where we're going to be installing operating systems, patching them, installing our applications and updating them. So when you look at this here, there's really quite a lot that must be mastered to do this successfully. And so at some point, some people started saying, well, all nice and well, but becoming an expert at running diesel generators is actually quite far removed from my core business. So what could we do about it? We've got this wonderful thing called a credit card, so couldn't we do something with that? You guys are very good at running those data centers, at building all that. Why don't you guys take care of that? And I'll give you a little bit of money every month, and we agree on some kind of interface. Your 19-inch rack, where I can come with my 124U servers and bring them in, and you provide me with reliable power and networking, and we're in business. And this is our classic co-location model. But even there, some people say, well, you know what, the whole relationship with Michael, it takes a long time, and we really don't want to deal with that. Can't you guys take care of that as well? And so we said, well, sure, we can do that. And this is our Hetzner, our OVH type of models, where for about 50 euros a month, you get a nice 7 server with 64 gigs of RAM and half a terabyte of SSD. This is the classic root server model as it's being offered there. Now let's bring things back to software. To see where you all stand, to get to know each other, I'm going to ask you to raise your hands and keep your hands up as long as what is up here applies to you. So, are you currently working on a project where you have an automated build? So the big question, I'm making sure everybody's awake. Very good. Who's got unit tests on their project? Everybody still? Very good. Who's doing CI? Pretty much standard these days, all the hands up. Except the one man in the back on the left here. Okay. Alright.
We're starting it up.
Who's got acceptance tests? The type of black box system test, Selenium WebDriver. Very good amount, very good. So we've got maybe 80-90%. Excellent. Who's doing continuous deployment of code? So we've got about just 40% or 30-40% left. Very good. And who's also continuously deploying database changes and code changes? Very good. So that's a quarter of you. And who's doing fully automated infrastructure deployments? We have, again, about a quarter left. Very, very good. Okay, so if you look at that workflow where we've got our source control on the one end, and we've got our CI system, which in a sense is a bit like a neutral referee that says, aha, all nice and well that you've committed something into your source control, but I'm going to double check to make sure that you haven't introduced dependencies on your local machine, or that you haven't forgotten to check something in. So I'm going to pull down the latest version of the sources, build them, test them, and produce some kind of artifact. And the artifact we produce has a number of qualities we've learned to appreciate over the years. The first thing is we produce one immutable unit. In the JVM world, for example, this would be a jar file, a WAR file, an EAR file, or this could be an RPM, a zip, whatever you want to have. And we don't really modify it after the fact. If something needs to be changed, we simply commit a change to the version control system and we run through that same process again and produce a new artifact so that we can then promote that one artifact unchanged from environment to environment. Why do we do that? Because we want to avoid the classic mistake of building a separate artifact per environment where at the end of the day you end up with a different artifact in production than the one you tested in test. So, if you look at the process that we've had there, and if you look at all the layers of our system, if you start from the hardware at the bottom, and then you've got an operating system kernel, and you've got some libraries and a language runtime with an app server embedded or not in the application, the process we've talked about so far mostly deals with these top two layers. And the question is why? Or what's so different about these other layers below? Why should we treat them differently? Or is there something fundamentally different about the bits and bytes that those layers are made up of? I'm not convinced. So if we keep this process in the back of our minds, if we actually want to get our artifact out there onto some machine, where we've got our target system here, we've got some artifact repository, we push out the artifact, we pull it down on the other side, we update it, and off we go. Not too bad when you actually look at this like that. Except, of course, that reality rarely looks like this. It looks more like this, where you have many machines in many different environments. And of course, any difference that you introduce between those machines, between those environments, is a potential source of trouble. So you must make sure all these stay perfectly aligned. But things don't just stay in place. At some point, these things will also need updating. You will need to apply updates on all layers, on all machines. So whose job is that? That's the system administrator. It's the system administrator's job to ensure that all the machines are properly patched and properly aligned across the different environments and that everything is working well. Now let's use our time travel machine once again, and we're going to travel a little bit further in time, about 100 years ago. This gentleman from the automobile industry had this famous quote: if I'd asked my customers what they wanted, they would have said a faster horse. And guess what? This is exactly what we got in IT. Instead of the system administrator, we now got the automated system administrator, better known as the chefs and puppets of this world, that are basically performing the same task as the system administrator. They're just a little bit faster, a little bit more efficient, a little bit less error prone, but they're still using some kind of recipe or some kind of template, and they're aligning different systems with each other. So the fundamental task hasn't changed. Now let's time travel back to the present day. This is a quote from AWS reInvent 2014 already, so it's about 18 months ago, the big yearly conference that they have in Las Vegas, and you really have to let it sink in to realize the magnitude of it. Every day, AWS adds enough server capacity to power the whole $7 billion enterprise. Amazon.com was in 2004, weekends included. So you have to think about it. That's yesterday, that's today, tomorrow, the day after, and again, and again, and again. It is just incredible. We have never experienced something like that before, because we've really shifted from a world of scarcity where you have to carefully look at what kind of servers you have and how you use them and request them ahead of time, to a world of abundance where you can have almost virtually limitless resources available to you. So this is really something that's very, very interesting, and will have a deep, deep impact into how we design our systems. The other interesting thing that the cloud brings to the table is a very clear separation between the control plane and the data plane. In this example here, we've got a nuclear power plant. On the left, we've got the control room, where you've got all the dials and monitors, and where you can make sure everything works well. On the right, we've got the pool with the submerged rods, where the reactions are taking place. So if you bring that back to software, the control plane would be, for example, your console, where you're kind of looking at what kind of resources you get there, and you can launch new ones, and your database, your actual instances doing work. Now the new thing here, of course, is that the control plane can be fully driven by APIs. You can have machines now provisioning new bits of infrastructure there, and something that's never been possible before, certainly not on-prem, is to shut them down again and stop paying for them. This is really something which I think is going to have an enormous impact into how we slice and dice our systems. If you have some kind of process that needs to run at the beginning of the month for a while you let it run for 5 hours, and when it's done, you shut it off and you stop paying for it until the next month. And I think for me, this is going to be a fantastic time ahead of us, the next 4 or 5 years. It's still early days. I think we're still trying to discover how to make best use of this. But the convergence of business and architecture into how we design and slice our systems is going to be an absolutely fascinating time ahead of us. And so in light of that new reality, I strongly believe it is time to rethink the faster models. If we start by assuming that what we have at the bottom there is just undifferentiated heavy lifting, where we don't really care whether that's physical or not, if we pull out the physical server and replace it by virtual hardware, we now have a number of new possibilities opening up. The first one is we can now start producing, instead of regular artifacts, actual images of entire machines as our product of our build. So that we can then push these machines, these images out to our artifact repository and pull them down in one go on virtual hardware. Why is this interesting? Because of course, the lower you can capture your application at, the higher the guarantee that what you've captured will remain exactly the same on all environments. And so we can go much lower than with traditional artifacts here. And so it means that basically we've gone to a world like this, to a world like that, where if you even design these machine images properly, they can run on multiple kinds of virtual hardware. And all the updates that we had to apply at individual layers on individual machines kind of vanish because they're built into the build process now. So that you can really have the same machine image that you can promote unchanged from environment to environment. But of course, there is one big problem left, is that the size of our machine images and the size of our network pipes don't really fit together these days. We've got a bit of an issue to deal here with. So what can we do? Well, let's turn to this. I forgot who I've got this quote from, but it's a very good one. Running servers in production should be like going backpacking. You take the bare minimum with you, anything else is going to learn. Now this is a picture I took about 2 summers ago. So you have to think, it's about 10 in the morning, Saturday morning, here in Bavarian Alps. We've driven down with my wife from Munich. We're about to go up the mountain, so it's about 1,000 meters vertical up, so it's a proper day. And so we're about to go up, and we see these 4 guys coming down there. So we start talking to them, and so they'd gone up the night before with a 20-liter wooden barrel of beer, with a 4 mass glasses, with the hammer, and so they drank it all at the top of the mountain, and they just come back down as we met them there. So when you think about it, it's actually the most inefficient way possible to get up that mountain. But yet, when you look at how we run our servers, this is exactly how we do it. We've got a 20 megabyte application, and we've got gigabytes of stuff around it that we carry around. And the question is why? So I think, if we're going to be trimming some of that fat, we should decide on a criteria to go by. And I'm a strong believer that we in our software business are there to enable the business. We are there to make certain processes faster, more efficient, to enable them to run at higher capacity than it could run otherwise. So we should really look at what is actually adding business value versus what is just technical ceremony. So if we've got our machine image here, we're going to X-ray into it, and we're going to look at the different components that we've got available here and see which ones are actually adding business value and which ones are just technical ceremony. So let's start from the top left, the application. That's what we're being paid to solve. So we're gonna keep that. But in a virtual environment, do I need compatibility with all binary formats or 32-bit CPU architectures? No, I don't. I'm going to keep the app server because I'll need that to run my application, but has a man page ever helped one of our customers when it sat on our production machines? I don't think so. Has a customer ever been excited about the fact we were running apt-get or RPM on those machines? No, goodbye package manager. We're going to keep the language runtime because we need that to run our software. But if my software, for example, is written in Java, do I need a C compiler on those machines? No, I don't. It is not 2006 anymore. The days of having 5 different terminals open with tail-F and some grep expressions and watching things scroll by definitely belong to the past. We don't want to hunt for log files or individual requests on individual machines. We get fantastic solutions available today with centralized log service. So log files do not belong on those machines. If I don't have my log files there, do I need a VI? Do I need an Emacs? Do I need other editors on there? No, I don't. Many random utilities I've got on there don't serve my application either, so we're going to dispose of them as well. And if we haven't got all these things, do we even need to log in? I say no. Goodbye SSH. If I can't log into those machines, do I need multiple users? What for? If the very things I set out to protect simply aren't there anymore, why do I need a firewall? Do I need multiple shells? No. Do I need drivers for tens of thousands of pieces of hardware when all I need to support are 3 or 4 virtual interfaces? No. I'm going to keep some libraries to let my language runtime work, and many random daemons we're going to dispose of, and the kernel we're going to keep as well to drive the hardware. And what we have here is the bare minimum, which is actually adding business value. And when we fuse all that together, we get what we call a bootable map. And this is a very different world. For a Node.js-based application, for example, this is about 15 megs plus the size of your app, so that's including the kernel, all the required libraries, the Node.js runtime, a bootloader, everything. For a Java 8 based application, it's about 40 megs plus the size of your app, and those 40 megs include the Java runtime environment, all dependent libraries, the kernel, bootloader, everything. And so all of a sudden, when you think about it, how it was complicated to push those big machine images over the network, how it was expensive to archive thousands of versions of them per year, all of a sudden, it's not that big of an issue anymore. We can archive thousands of versions of that. We can push that quickly over the network. So it kind of opens up a whole bunch of new possibilities. Now I know a number of you are thinking right now about a bunch of cases where this would never work. But it doesn't matter. Just use it for everything else. Because as much as we would all like to be thinking that we're building the next Facebook, that we're building the next Netflix or the next Twitter, when we go back to the office tomorrow, we realize that we're probably working on a project where we just need to get the job done. We aren't pushing the boundaries of technology, we're just there to make things work. And so the typical 12-factor app, cloud-native microservice is a perfect fit for this. So, to show you that this isn't just a whole lot of hot air, but it's actually real, I'm going to do a bit of a demo with our software there, with BoxView. So I've got a Node.js app prepared here, but we're going to modify it now because if the demo isn't live, it can't fail, so we have to make sure we introduce a bit of randomness here. So let's just say hello Einstein. And save, no, it's exclamation marks, there we go. And quickly going to switch here to the terminal, re-expand this window up. Is that for a font size readable or the limit? Okay, all good. So the first thing we are going to do is bundle this Node.js application up. So we're just going to do a quick npm bundle. It's going to generate a tar.gz file. Should take about a second. Let's see, or 2 or 3. It's, there we go. So we've got the tar.gz file. And the first thing we're going to do now is we're going to create a machine image for it. And we're going to run it on, going to launch an instance of that and run it on VirtualBox. So, off we go. So the first thing that's kicking off now is some analysis process, where we basically looked at the current directory, and we found some kind of firewall permission problem. No, just kidding. We found some kind of artifact in there. We found it's a tar.gz file that requires Node, so we pulled in a Node, the Node runtime. The Node runtime requires a C library. We pulled that in. That requires an Linux kernel. We pulled that in, and we pulled in a bootloader to make all that work as well. And then we started a new instance of that. So our image was created in about 1.7 seconds. It's about 15 megs in size. And then we launched a new instance of that on VirtualBox. So we discovered that we need to open one port, an HTTP port, at port 80. We forwarded it locally, and in about 3 seconds our instance was up and running. So these are the boot logs from our instance. We're basically issuing a DHCP. We're getting an IP address, and then basically we received an HTTP 200 of our service at that address. So I'm just going to copy paste this guy, and paste it here in the browser. There we go. So that's basically our brand new machine image, or an instance of it running on VirtualBox. So what have we got exactly here? If we kind of have a look at the images that we've got, so this is the image that we just created here. So it's based on Node.js 6.2. This is the one port that we forwarded. That's the total size created now. And if we've got, let's see what we've got running here. We've got one instance running on VirtualBox of that image by the same number of virtual CPUs as the physical machine by default, and a gig of RAM configurable, of course, and at that URL. So the nice thing we can do now is we can promote this unchanged to a different environment. So we can say, let's take this guy out, let's take this image out and push it out to AWS. So we're not rebuilding an image. We've seen that it's basically stayed the same. So we're doing a quick push out to our central secure storage there, and then we're going to convert it to AWS. So when the image was created, we've actually created 2 different parts. There's this image, and there is a descriptor. The descriptor contains a bunch of metadata about the kind of ports and health check URLs and a bunch of things that we're using that. So when we're launching an instance of that image on VirtualBox, we're taking the disk image as is and converting that descriptor to VirtualBox, to a VirtualBox specific format. When we do the same for AWS, we're again taking the disk image as is and converting the descriptor. So in this case here, we're creating an EMI, an Amazon machine image, which is the format that they use to be able to launch instances from. So this usually takes between 30 and 50 seconds. Kind of depends how quickly they work today, or how much load the systems are here in Frankfurt. So let's see. This is always the fun part, totally out of our control in the demo. But let's give these guys a few more seconds. There we go. So it'll be a bit longer today, 56 seconds. We did a few more things. We've created an elastic IP address, which is an IP address that you can remap from one instance to another. We've created a new domain name. We've associated that elastic IP address with that domain name. And we've created a security group, which you can think of as an external firewall and software-defined network, where you define rules about how certain nodes can communicate with each other on certain ports. We've then launched a T2 Micro instance So that instance is a gig of RAM and one virtual CPU in Frankfurt, and that took about 27 seconds. We've then created a CloudWatch alarm for auto recovery in case the underlying hardware becomes impaired. We've waited for that instance to boot. It booted in about 300 milliseconds, and then we received an HTTP 200, and we have then remapped our Elastic IP address and the domain associated to that new instance, and we've been up successfully. So let's just copy paste our new domain name, that URL here. Gonna paste it here. So this was all with no prior configuration or nothing set up. It's really from scratch. So what we have here is our same application up and running in Frankfurt that basically from an image that didn't exist 2 minutes ago. Now, let's go and modify this now to see how that works. So let's just say hello again, up, an exclamation mark, save. Gonna pop up the version as well, so let's go here and say it's version 001 now. Save this, and just gonna delete the old zip file and do an bundle again. Now, as you've probably seen, so this is just a regular Windows laptop, and it's not a Linux machine. This is the reason why Chris is sitting here at the front, looking at me like that, because he once told me, you know, Axel, there's I don't know what I hate most about you, but I think it's the fact you're a Windows user. So take that for a friend. But anyway, that's all good. I like it. So off we go. We're going to run this, and we're going to go directly on AWS. So what we're seeing now is, okay, we've detected our new image, created we've detected our new TarGZ in about 1.7 seconds. We created a new image for it, and we're going to push it straight out and see how the update process works. So if we kind of go here, so we see that our existing infrastructure is still up and running. We've pushed out our image. We're going to convert it to an AMI again. This is going to be a new AMI that's being created, so the old one still exists. Again, still up and running. So we live in a world of abundance here, so we don't need to replace things in place. We can expand our infrastructure footprint there without worrying too much about it. So let's see how long they need for this one. Probably scrapping there, quickly copying over from one diskette to the next to be able to get this organized. So it's late for them as well. They've had a long day of doing all that in Frankfurt. Or maybe they're out watching the football, who knows. Let's see. So it's the kind of moment where you need a bit of a drum roll to kind of see how it all works. So there we go. So they need a minute for this one. Creating a new security group, so we're leaving the old one untouched. We're launching an additional instance, so the old one is still up and running. So the old one is still up and running associated with the domain. We're launching a new instance there, so again this should be around maybe 30 seconds or a bit more. Let's see how long we need for this. This is the kind of situation my wife will never understand. How can we look full of suspense at those things at a black and white screen? But okay, so we're currently reassociating the things, so the old one's still live, and we've switched to the new one at the existing domain name, and we're up and running, basically. So shutting down the old infrastructure now, so we've expanded our infrastructure footprint, and we're contracting it again. Okay, let's go back to the... So if you look at that, it's probably a little bit different from how most of you are deploying your software today, and how you're dealing with these things. And those changes have a number of implications that are important to keep an eye on. The first one is really that we have a bit of a shift in focus, where in the past, an individual instance used to be really front and center, where we would really care about specific machines. This is not really the case anymore now. We care about the overall service. The overall service should be there. The overall service should be available with sufficient performance, with the right availability, and individual machines don't really matter anymore. Individual instances become disposable, so that we have the famous saying of treat your service like cattle instead of pets, so that we move away from the model where we've given them a cute little name and we've made them just perfect and that's so sweet, to a world of mass production. It's just anonymous, give me another 10 of the same, and here, and or another 20 of those, and that's no problem at all. So we're really detaching ourselves emotionally from those machines, and that's actually quite a good thing, because the minute you don't need those machines anymore, the hard truth is that this is how they end up. So it is a brutal world indeed, but you have to be prepared to live with that. And what we're effectively doing here is that we're deprecating the U in CRUD for service. We are still creating machines, we're still accessing them, we are disposing of them, but we're not updating them in place anymore. CRUD for service is dead in a world like this. And it's actually not a bad thing, because we come from an industry where we used to proud ourselves and look, I've got this Linux machine and I haven't rebooted it for 3 years, it's awesome. And unfortunately, maybe it's not that great, because the longer an instance has been up, the harder it becomes to recreate exactly or create another one like it. And the hard truth is that it will fail eventually, whether it's due to software or to hardware. There will come a point where you will need to go through that process. And this is really something that is actually quite important, that the high availability that we used to see as an asset in the past is actually, in many cases, more of a liability. The other interesting thing is, how do I know where my stuff is? If service A is starting to service B, but service B is coming and going, and there's new machines and old ones, how does service A still know how to talk to that other service? So that's really the field addressed by services covered, and we've got a lot of action there these days, and we've got a lot of tools competing, from the good old zookeepers to the consoles and the Eurekas of this world playing a role there. But if you take a step back and look at when those tools were designed, you actually find that a lot of them were designed for a different era, either from the on-prem era or for an era where you couldn't have internal, at least on the AWS side, for Eureka internal load balancers between services. You could only have internet-facing load balancers for Eureka. So I think that there's a simpler way and a much nicer way to look at this. So if you kind of look at our current definition, our accepted view of a service and its current boundary in the industry, if you have multiple instances, I think the days of kind of having database-based integration between services is something that is rapidly being relegated to the past. These days we want the database or storage to be private to the service. Why? Because you then enter at a much higher level of abstraction with better validation, and you're not messing in with the low-level internals of a service like that. So this is a bit of our current view of what makes sense for a service boundary. What I'm proposing here is to extend this a little bit and give every service a single, stable entry point with an internal registry. In our little demo, that stable entry point was the elastic IP address and the domain associated with it, and the internal registry was the elastic IP address remembering which actual instance it had to talk to. If you have more than one instance, you can use an elastic load balancer. For example, for this, an elastic load balancer will then forward the traffic to the individual instances behind that. And as a consumer of that service, if you call that service and it's currently got these 3 instances up and running, or it's got 5 different ones 10 minutes from now, it's not your problem. You only need to remember the address of the load balancer. And the load balancer will remember which instances are currently healthy and ready to serve traffic. Just like during our little demo, where the elastic IP address remembered which backend server was associated with it, and it was not our problem. We could just press F5 in the browser, and we would get redirected to the correct instance that we wanted to talk to there. So this is really something that really simplifies your overall view of your architecture, because this is a very nice Lego brick that you can then use, and you can click all them together like that by hiding completely the internal complexity and how a service like that is built up. So this is really very, very nice. So when doesn't this work? Very few cases actually. The one thing that you have here is that the traffic has to flow through the load balancer. So not that big a deal when we're dealing with our regular type of web or REST services over some kind of HTTP or HTTPS. No issue there. When you're streaming 4K video between different pieces there, it's probably going to kill those machines. But that's more of a rare use case. So, security is another interesting one. In a world like this, I could almost rephrase it as, when was the last time your toaster got hacked? Because when you come to look at it, with all things being equal, the more moving parts you have, the higher the likelihood of one of them failing. I'm a strong believer that complexity is the enemy of security. And we've really gone very, very far in removing as much of that as possible. We've really reduced the attack surface to the absolute minimum possible. Just our application and the direct dependencies actually solving some business problems. The other interesting thing, of course, is that if for some reason you were still getting Trojanized, well, the impact isn't as long-lasting anymore. It's much shorter. If our first instance in our demo had been Trojanized, well, guess what? 2 minutes later, it was already gone. So you haven't really set up something that you can then keep for the long term there. And the other thing really quite interesting here is that when you look at a traditional server, a traditional Unix machine, if you break in, we actually have all the tools at our disposal to break into further systems. It's as if you break through the front door of a house, and then you get presented with a chainsaw, with a hammer, and all the other tools. You can break through all the other doors. We get all these fantastic Unix tools readily available for us to then go and attack all these other systems. It's just insane. So we got rid of all of those. So if you get in, you can't do anything. You're stuck, which is actually quite a nice thing. Now, configuration is another interesting thing, because you may say, oh, well, you know, Axel, all nice and well, your image is the same everywhere, but I don't want to connect to my development database for production and vice versa, so how do you deal with that? Well, I think as a general rule, when approaching problems, you should always aim for the simplest thing that could possibly work. And so, in this case here, a very good solution is to aim for baking as much configuration for all your environments directly into your image and selecting at runtime automatically the set of configuration that you need for your current environment. Now, there may be cases where you're saying, well, you know, we don't really feel comfortable with sharing some of those aspects of the configuration, maybe some passwords or some other things in there. So even there's there's a lot of questions to be asked. The first one is, of course, well, why don't they trust you with a password? Would they trust you with injecting as much code as you want into that system that you could trialize everything? That's a different question. But you can then still say, well, it's not an all or nothing. So you give all the harmless properties, you bake them directly in the image, and the other ones you don't, or you ship all the properties in there, but you encrypt the ones that are sensitive and only ship the decryption key on startup. How can you do that? Every virtualization solution out there, every cloud provider out there, gives you the possibility to pass a little bit of arbitrary data when you launch an instance. On AWS, it's called user data, for example. And so you can use that data for doing things like maybe shipping a shell script that could, when you run it on startup, expose a number of key value pairs as environment variables and make them available for your application, so that you can then say, well, all your property, all your harness properties are baked in, but this is your password. Or, for example, this is the environment for which you should load the configuration, or this is the decryption key that you can use. So you have actually some very nice mechanisms to pass those things in there. And of course, this does not preclude the use of config servers or other means which you can also move to when you hit the limits of those type of mechanisms. But you can go actually reasonably far or very far indeed with these things before hitting limits. Now the database, or state in general, is another interesting thing, because if we're going to be disposing of our instances very regularly, we don't want to have persistent state exclusively on one of those instances. Doesn't mean that you can't locally cache certain things, but you should be prepared to lose everything that is on an instance. This means that you have to put it out there and use either some existing services or build your own systems. So this could be for relational databases on AWS, for example, using Amazon RDS or Google Compute Cloud. You would use Google Cloud SQL or what you choose to use there, or you can use some DynamoDB or so, whatever technology you can use out there, or you can of course build your own, as you've done in the past as well. So you can just as well set up your own database servers with their backups, their replications, and all that. The hosted services have the advantage of being incredibly convenient. We've been using Amazon RDS Postgres for the last few years. It's been tremendous. You tick a box, you've got it geographically replicated, you get point-in-time backups, you can restore to exactly 8:45 last night and get that exact state. So it's really very, very comfortable and very nice to work with, but again, I think the possibilities there are quite numerous of the approaches you can choose. In case you're using a relational database, again, think about using a database migration tool to update the schema on application startup, so you ensure that they always fit together. Again, here I would say use the simplest tool that could possibly work. I do not want to influence your choice as to which one this should be. Just pick the one that would work for you. Now the logs, we already talked about it, the days of having ~f across all different little windows with some grep expressions is really something that firmly belongs to the past. So we don't want to do this anymore. Instead, we have very good solutions available in the form of centralized log servers. This has the advantage of having all logs shipped in one central place where they can be aggregated, they're being indexed, they're being backup, they're searchable, you can define alerts on them. You don't need to give permissions to access individual production machines, not even read-only permissions. It's nicely shipped out. Our networks are very fast, so there's a high likelihood that you don't even need to buffer on disk as you're sending things out. You can send them directly by HTTPS over the 10G network, and that will work just fine for the vast majority of the cases. So we've got really, really good solutions out there. Whether you choose to build your own with Elasticsearch, Logstash, and Kibana, or buy into solutions like Splunk, or use hosted solutions like, for example, Logly, Logentries, or Papertrail. They provide deep integration with many frameworks available out there. So if you're on the JVM side of things, they provide, for example, integration with Logback and Log4j. They will give you a little XML snippet which you can copy-paste in your Logback for .xml, for example. You shut down your application, start it again, and you start sending your logs to the centralized log server there. So lots of very good solutions available out there today. Whether you're on-prem or in the cloud, there is no excuse whatsoever not to be using this today. Now, sessions is another interesting one. And as an industry, we've really had a surprising amount of bad ideas as far as this is concerned. So So if you come to look at where it all started, where we just had what our sessions at the end of the day is, and the main point of a session is really to identify who you are when you're using a specific device. It's not a general purpose cache for a whole bunch of things. I think there's some really bad offenders in terms of frameworks for that. If you look at the JSFs, the Vardins, the wickets of this world, they're doing a terrible job at that. It's storing all kinds of component statement in there. But for every sane framework out there, it is primary to remember who you are. So it's a pointer with an ID. And it's basically at the end, it's some kind of reference to a data structure where you can then recover more data about that one user. So the first thing that we did, well, we had it on one machine, so shut off the machine, they're all gone, so not really great. So we looked at things like clustering, let's bring a couple of machines together and do that. So the problem there is, of course, as the number of machines expands in your cluster, it starts to eat up a lot of RAM in each individual machine because every session needs a bit of space in RAM. It creates a lot of chatter on the network as well. So we start looking at things like peer election and just having a machine selecting a peer and just synchronizing amongst the two of them within a cluster. But even that wasn't great. You still had RAM eventually filling up, and then horrible things like session timeouts had to be introduced now where you get 30 minutes and your customer's writing their complaint letter and takes 30 minutes and 15 seconds and press send and poof, and your session has expired. So just horrible things. So we looked at shifting that complexity to the load balancer instead, with sticky sessions and session affinity, and then performing session draining as we're upgrading our software so that you bring the new version up and then you only send new sessions to the new machine, but that can take a long time. In the world of continuous delivery, definitely too long. If somebody in Munich, some office worker logs in to their machine, they're logging at 8 in the morning, that session could last 8, 9, 10 hours before it expires, so it's definitely too slow for our modern world, and that's in the luxury situation where you're not in a 24/7 environment. So what can we do? Well, we can look at what other platforms have been doing all along. So if we look at what Rails has been doing since version 2.0, if you look at what ASP.NET has been doing, if we look at what the Play framework has been doing on the JVM side of things, well, they store the session in the cookie. And this is actually quite interesting. If you sign the cookie, you can make sure it's not being tampered with. If you encrypt it, you make sure it cannot be read. At least you have, to the best of our knowledge, with AS256, a few decades of security there. So your secret shouldn't outlive the security, but if you've got a short-lived secret, that's no issue there. And this has really quite a few nice implications. So we can get rid of all these horrible things, like session timeouts and all the complexity of clustering and replication and sticky sessions and server affinity. All that kind of goes out the door. And it lets us use our resources much better as well, because instead of filling up our RAM on our server with all these sessions that are idling most of the time between requests, instead we kind of outsource that storage to the individual clients, where each in their cookie store will store the session data, and you only need to have enough RAM on your machines for the requests that are being actively processed. And so this is a very different proposition, because it means that you either, with the same machine, can process a lot more, because you don't need that storage available for those sessions, or you can downsize to smaller machines and process the same amount. You can literally have millions of sessions being handled by one machine, as long as the number of concurrent requests is something that machine can handle. Now, what about rolling out new versions of the software? We've seen this a little bit during the demo. So if we've got an application up and running, I'm here in version 1, we've got a load balancer, we're sending a request to it, it's kind of getting some data from the database. That application itself will be running in an instance that's running in a so-called availability zone, cloud terminology for one or more data centers within a specific geographic location. If you want to have this highly available, you run it across multiple availability zones, so they will be usually on different sides of a large city, where you then will have different flood areas and isolation for a good number of natural disasters, so that the likelihood of both of them failing at the same time is actually very low. So our logs, we send them to a centralized log server and our sessions in the group. When we want to roll out a new version, we don't live in a world of scarcity anymore. We live in a world of abundance. So, if I've got 10 instances of version 1, I can now start up 10 instances of version 2. I make sure they're healthy. If they're all working as expected, I start sending traffic to them. I cut off traffic to the old one, and I shut off the instances to version 1. Now, if these instances were like in our little demo, if they're T2 micros, for example, and you've launched 10 new ones for that 1 hour, so you get a bit of overhead there. Your 10 T2 micros that you've launched redundantly there will increase your total monthly bill by 10 cents. That's it. So it is really quite a different world from the world of on-prem we've been used to. Let's talk about the elephant in the room. What about containers? What about the less level virtualization? What about the Dockers of this world? How do they fit in a model like this? To be able to answer that question, we must first take a step back and understand how modern CPUs work. For the past 10 years, since 2006, all CPUs shipped by Intel and AMD have had hardware support for virtualization. This has brought two things to the table. Isolation of individual guest systems running on a physical host, and a performance penalty by being able to access those individual guests or those guests accessing the outside world. Now, every subsequent generation of CPUs has worked very hard at reducing that performance penalty by adding new instructions for better performance, for entering or exiting VMs, for better performance with networking, with single root I/O virtualization, with better performance for storage, and for all kinds of things around it, to the point where today on 7 KVM, you're within 2 to 5% of native, but there's still a gap. Now, on-prem, which one should you choose? If you've got a VM, you will have some hardware at the bottom, some kind of hypervisor, and then some image, bootable app or classic, doesn't matter, on top of that, and the blue line here is really the isolation at the hardware level. If you've got containers, you will have the hardware, you will have a base operating system, you will have a container runtime, and then some image running in that. So, the interesting question to ask here is, how homogeneous is your workload? Can everything run on the same version of the Linux kernel? Can you, and if you don't need Windows-based workloads, if you don't need things like live migration, for example, which are a lot more mature on the VM side, then I think containers can be a fantastic solution here, because you don't need to pay the performance penalty of that blue little line there, of that isolation, because you live in a friendly environment. Your applications are not going to try to actively Troyanize each other or sabotage each other. So this is something where you can really look at what your actual workload is like and what makes the most sense there for you. Also, of course, considering things like previous investments and so on, in one direction or the other. At the end of the day, we've seen it at the beginning, it's all your responsibility anyway. From the bottom up, all the layers are your responsibility, so you have to look at what makes most sense there. On the cloud, regardless of whether you choose to go down the VM or the container path, you always have the same base that's being offered to you. It's a hardware and a hypervisor. The hypervisor being like 10 KVM, Hyper-V, whatever the cloud provider chooses to put in there. And then on top of that, you then add your things, which could either be a VM image classic running, or you can have then some kind of VM image where inside you would have a base operating system and a container runtime, and then some kind of image in there. So these are really the two choices available there. So how can we decide? If we think again about our control plane and our data plane, the control plane is really all the services that are credit card biased there at the cloud provider level. So if you look at all the management of machine images and the AMI we registered during the demo, you don't really have to care about setting up a registry and having enough storage for that and vacuuming that and make sure it's reliable. It's kind of taken care of for us. We don't need to come up with a scheduling solution to make sure our instances launch on the correct physical host. And that these things work well and that they're balanced, that's taken care of for us. We don't need to worry about calling Michael in time when we need to add more capacity to our overall cloud. That's what they do. They take care of planning the capacity ahead of time for us. We don't need to worry about storage and volumes and having everything in place and all that infrastructure is taken care of for us. We don't need to worry about software-defined networking and communication amongst different hosts. It's all kind of taken care of with the fees that we're paying then for the usage of the service. If you look at, if you introduce containers into the mix, that's within your responsibility, within the data plane, you now have to look for solutions for those problems again, because you're effectively introducing a second layer of virtualization, and that one falls under your responsibility. So you now need to find a solution for managing your container images. This could be a hosted solution somewhere, or something you run yourself, but it's still a decision you need to make. The same thing applies to scheduling, and being able to run all that within a cluster. Again, there are some solutions that you can use. You have to make decisions as to what makes most sense for you. The same for the capacity of your clusters. You need to make decisions about how big you want to size those clusters and kind of set the things up to scale them accordingly when you need them. Same for managing volumes. You need to come up with a good solution to map the container volumes to some underlying physical things and making sure they're replicated and that those things work well. Same thing for software-defined networking. You need to come up with a good solution that you can use there. So you can use, again, existing tools there, but it's still your responsibility for running all that and making sure you make the right choices there. So, how to decide? Which one makes the most sense there? We have to think business, technology, and we are kind of there to enable the business. So let's look at what these things cost. If we look at a €5 bill, for example, what does €5 buy me? It's about a month of T2 micro capacity running 24/7 in its most expensive form that is unreserved on demand. So this is half a gig of RAM and one virtual CPU. 1 month is actually not true, it's more, it's about 40 days. So it's about a month and a week and a half, more or less, that you get for this €5 bill running all the time. So if you bring it back to 1 hour, it's about half a euro set that such a VM costs you. And this is really the smallest unit of granularity you can work with when you work with VMs at the cloud provider level. So, the question to ask is, can you afford as an organization a granularity level of half a euro cent per hour? Are you able to accommodate that in your budget, or are you saying, no, this doesn't work for us, we need to further subdivide that, and then you can invest the engineering effort to run that second layer of virtualization to get more out of that. I think what really matters here is to focus on the right thing, and the right thing is really the total bill that you get presented at the end of the month, and not individual resource usage. It doesn't matter if one of these instances has 200 megs of RAM that are used. Who cares about that? It's really what you pay at the end of the month that counts, and that's really the total cost, both in your cloud provider fees and in the amount of hours that people need to spend on setting up and maintaining all that infrastructure. So that's really what you should keep in mind, and that should be the driver for your decision as to what makes the most sense for you or not. So, if we summarize all that, we've taken the principles that we've learned to appreciate over the years for our artifacts, where we've created one immutable unit that we regenerate after every change, and we promote unchanged from environment to environment to avoid the classic mistake of building a separate artifact per environment, where we would have a different artifact in production than the one we tested in test. And we've applied those principles to the remaining layers of our stack. To make it practical, we've seen that minimal images are a very important enabler for that. And I think one of the most fascinating developments for the next 5 years will be the business and architecture converging and having us design and slice our systems in such a way that cost becomes a very important point of focus. So I think it's early days, but this will be absolutely fascinating for the years ahead. So you're more than welcome to run with all those principles and implement them yourself. If you are on the JVM or on Node.js and deploying onto AWS and you've enjoyed it, or those things resonate with you, you're more than welcome to check out the work we're doing at BoxU. So it is a freemium model. It's not 100% free, but you get one application for free with an Elastic IP, and then if you want more, then it's a very reasonable fee. Otherwise, I would say this normally should have been my last slide, but it isn't. I'll get this one for you. Thank you very much. Now, I made a deal with the camera crew that Christian would be my servant and would run around with a microphone. So, are there any questions? Yes, make him run, make him run. The next one in the front, please.
Yes, you mentioned that containers actually are in the second level of virtualization on top of it. What about container services from Amazon and Google? Basically, they have optimized environments for containers already.
So I think it's, the question is the second layer of virtualization. What about the things like ECS from Amazon? How does that fit into that picture? So yes, it still runs within your VMs. You have some kind of agent that you run there within your VMs, and you provide you with a bunch of things to make your life easier. So Amazon these days will provide you, if you choose to use that, a registry for your Docker images, for example, where you can push and pull from. Amazon will, with the agent, take care of certain things like scheduling and having those things balanced. Just announced last week, they finally introduced auto-scaling into the mix as well to take care of those things. So there is definitely some developments happening there, but that doesn't take away the basic fact that you basically piled up additional layers of technology on top of each other, and that basically the instances are still fully in the data plane, fully under your responsibility, even though you're running part of their code with the agents. It's not a managed service, it's still something where you're fully responsible for patching and updating them and taking care of those things. So yes, there is some help, but you're still piling on a lot of things in there that you need to take care of. Very good, at the back. I like it. Run, Christian, run.
I don't have a question, I want to make a remark. I'm not convinced of that, because for me it's like you have a working horse and you have a race horse now, but it's still a horse, if you keep to your analogy. Because a VM is a VM is a VM is a VM. It doesn't matter if it's small or big. And it means you have a lot of cattle now, and I don't want to have cattle. I mean, I've grown up with mainframes, and if you think about it, actually, the cloud is kind of a mainframe if you want. And if you have a nice cloud, it means it gets rid of all this shit called load balancers and all that. But if you have VMs, you're still to the classical wiring of things. You have to still find out solution for load balancer, and if you rely on AWS and so on, this stuff is not standardized. So that means you become not agnostic to the cloud provider. So that means for me, Docker is giving you that second level of virtualization where you can. So if you say cost is a matter of things, I don't think it's cost, because the guys I work for usually as clients, for them it's time. They pay a lot of money if you tell them they can get things faster. So these are just the two things I want to say.
Okay, well, I think fair point. I think the thing that you shouldn't forget with that is the ability to be able to change cloud providers, something that's being pushed forward by a number of tools these days as well. And you get Terraform pushing in that direction, you get a bunch of things, but I think for me this is the early 2000s all over again, where you had ORMs and abstracting between different databases, and how often did anybody ever end up switching from Oracle to SQL Server? Never. So this is, I think, very much something that we're seeing now as well, where I think you can either go for the smallest common denominator between those platforms, or you can choose to actually leverage the investment that you made. And yes, there is a bit of a locking there involved, but I think it's an illusion to think that you can just change without any kind of locking as soon as you start depending on things like fine-grained IAM permissions and other things in your infrastructure, which don't necessarily have a one-to-one mapping for other cloud providers. You will have to do some reworking, you will have to do put in some effort to make those migrations happening. So I think it's an illusion to think you can just do like that and it will change anyway. So you might as well use the power of what you're paying for. But I think we will agree to disagree on that.
I'm just trying to make a remark on the remark. So, excuse me, but the problem is you can't buy a half mainframe. And I can get 5 times a machine the size of your mainframe within 5 minutes and any data center on Amazon. You can't get that. That's the difference. You are toast with your mainframe when I come in with any of these solutions, and Amazon is not the only one.
Anybody else? Someone at the back maybe to make Christian run again?
Yes. So I have a question then.
Yes.
You didn't mention the term unikernels. Does this have any relation to unikernels and the thing that's acquired by Docker?
I think it's an excellent question. I think certainly since last November at DockerCon, unikernels kind of burst a little bit closer to at least mainstream awareness, or a lot of people became a lot more aware of them. I think that the base principles are very, very similar when you kind of think about the idea of stripping things down to really what's needed, and having some very slim image that you can then move around, and all the security implications of that, and how that works. I think there's a lot of very similar things. I think unikernels today have a number of important unresolved challenges. The first one is that many of them are very programming language specific, so you then run into some issues there. I think the other thing that's important there is also from a licensing perspective, a lot of things are unclear. Many of the common licenses, if you look at the GPL, the LGPL, which are used for a lot of things, are developed in such a way that processes should communicate at an arm's length and cross a process boundary to avoid the viral effect of those licenses. This is something where you don't have individual processes in a unikernel, so still unclear. So just something to keep in the back of your mind in case you're going down that avenue. And I think also just the fact that you don't have those individual processes, having things like fork and other things that we take for granted in a lot of the software that we use, isn't there anymore. It requires a lot of rewriting. At this point in time, I think things will mature, things will evolve. But at this point in time, I would say they're toys. And this will certainly change, but I think, and there will be a lot of money being poured in to change these things. But at this point in time, I think it's, I'm not sure how wise it would be to bet on that for production machines. For an experiment on a weekend, yes. For running your production environment on it, depends.
sort of stuff.
So what about Azure cloud? Something that you have considered? Is it possible actually to create these images for Azure cloud?
I think it's a very good question. So Azure is technologically, they're investing a lot in it right now, and all the different things are, all the different base components are certainly in place to be able to do the type of things that I demoed there. It's not living with restrictions like DigitalOcean, for example, where you cannot have custom images from scratch. In Azure you can. So that's not a problem there. So both Azure and Google Cloud are also fully capable to have those type of things running on them.
Turning back to the question of the kernel of the operating system. Back in the old days, like 20 years ago, we released software by making a build, like having to compile and producing a binary. But if I look at this architecture, begs the question, do we need any operating system anymore? Or when I go down to micro-scaled micro machines, would it be just fine to put on one executable that operates the small thing?
I think it's the definition of operating system is something that's been shifting. I think if you look at the general purpose operating systems we're used to today, and the Ubuntu, the Windows, the Microservices, the Red Hats, they're very different beasts to the stuff that I demoed, to the unikernels we just talked about. So I think that when it's really still pure operating system, when it's really just single purpose and just doing one thing instead of a general purpose thing, I think that's probably a matter of definition at some point. But yeah, I strongly believe that the days of general purpose operating systems are numbered on the server side. So I think that's certainly something, and then whether there will be a process boundary between individual components running there or not, that's something the future will tell. But I certainly think that the days of having a fully fledged Ubuntu or Red Hat or CentOS on your machines is something, let's say it will look very different 5 years from now, from where we are today.
I believe that's it. Thank you very much. A great talk.
Thank you once again from my side, all for coming. I've got some flyaway and some box view stickers as well if you want to pick your laptops. Otherwise, they'll be here outside. Thank you very, very much.